I'd just like to go over some of the things that we're doing at EPRI. EPRI works with utilities across the country and actually worldwide to try to help them to help their customers to get to solve some problems and to give them the power they need to run their large facilities, whether it's a data center or it's telecom central office or whatever, in an efficient manner. So what we've got is we're involved with several different universities, several different electric utilities, and actually the telecom industry to try to get some demonstrations going and to prove what we've already started to get good data on how to run data centers on 380 volts DC. And we're also doing a lot of effort to try to develop a specification on what the facilities has to do and what the telecom or data center computer equipment has to do in order to run this way. And so we've got a group called the DC Power Partners that has been around for about 5 years. We're joining the eMERGE Alliance to utilize their expertise. They've already done a 24 volt DC specification for running things like lighting within buildings and everything from projectors to chargers for all the electronic equipment that you've got. We're working with the European Telecommunication Standards Institute. They're looking at converting a lot of their telecom central offices from 48 volt DC to 380 volts DC. And we're also working with the IEC to what they consider low voltage DC, which is anything under 1500 volts DC. So they've got a slightly different philosophy on that. But we're also working with many of the manufacturers to develop products that we can actually plug and play with the existing servers, because the servers really don't care what the power supply input is. They need a certain amount of wattage at like 12 volts, 5 volts, 3.3 volts. So we're working with a lot of facilities around the world where we've got some 380 volt DC demonstrations going, and they've been so far very successful. We're getting ready to expand several of them. Several of the companies like Nippon Telephone and Telegraph are looking at converting their data centers and telecom central offices to 380 volts DC. And why 380 volts DC? Okay, there's a bunch of reasons why 380 volts is kind of like a sweet spot, a magic number. If you go higher, you can get even greater efficiency, but you start running into regulations and things like the National Electrical Code and the equivalent around the world. Higher is not necessarily better in their minds. You've also got things like existing power supplies. You would like to be able to use just a slight modification to existing power supplies in order to run the rest of the facility at 380 volts. So when you look at all of the things that are going on, regulations, batteries, power supplies, 380 volts is kind of like a natural number in the middle there that gives you most of the benefits without major drawbacks. So I don't know if many of you are aware of something called the ITI Sabima curve that identifies, for the normal 208 volts that goes into a computer, it can vary up and down and still have the computer and the power supply operate properly. You can't go outside of the window too much, and not for very long anyway, without the power supply either shutting down because of lack of power or getting damaged because the voltage is too high. And we're creating the same thing for this 380 volt DC philosophy, where what range does it normally run over, and what range can it go for a short period of time without damage or shutdown. So we're having to create a lot of these new structures the way that we've kind of developed them over decades for the AC system. And this is a kind of a block diagram of what's going on in and the 380 volt DC facility as well as the IT equipment. Basically, you take the 480 volts, three-phase AC power, and you rectify it, and you create 380 volts DC. And what you do in order to keep touch current and the voltage is down, what you do is you center tap it, so it's actually plus and minus 190 volts DC. That you feed directly into these slightly modified power supplies that have already created the 380 volts DC in the standard AC power supply. What you do is you pull off the front end of that power supply and you just feed the 380 volts DC directly into it. So what you've done in that case is you've actually gotten rid of two conversion steps. You know, instead of going back to 480 volts AC, sending that throughout the data center in order to then drop down to the PDU normally has another transformer in it that goes from 480 volts three-phase to 120, 208 that then feeds into the computer power supplies. So you've actually eliminated two conversion steps and got rid of all the wasted energy with that. One good advantage of the 380 volts DC is now you can start to think about things like using the PV panel on your rooftop or on the top of your garage or whatever, and actually feeding that into the data center as well. And you know, if you've got excess power, you can actually send it back out to the utility or use it within the data center. So there's other benefits that you have of this 380 volt installation. What you got is you can now use that 380 volts directly for variable speed drives. You can, within a home, we're actually looking at what you can do not only in data centers and telecom central offices, but what can you do in residences. And some of the higher wattage appliances you have in your home, like your oven, the stove, these washer dryers, you can actually run at 380 volts as well. And also, one of the things about these new plug-in electric vehicles, if you use the normal 120 in your house, it takes 10 hours or so to fully recharge your battery. If you've got 240 volts in your house, which most of us do for things like the higher wattage appliances, you can cut that down to about 8 hours. But if you use 380 volts DC, you can recharge your plug-in vehicle in 30 minutes. So there's a lot of things you can do with this voltage. And we're also looking, like I said, with the eMERGE Alliance at what else can you do with DC. And there's 24 volt uses for, like I said, lighting, projectors, TVs, because you know, all of your electronic devices in your home basically have a little brick that takes the AC and converts it to DC. So why not just distribute DC around? So there's challenges with this DC. You know, it's a little novel. We're getting all the products and all the components through the safety agencies, just like you have to do with the AC products as well. Okay, so it's just a little bit different. And you know, we're getting UL approval on all of these products. It's a paradigm shift. It's going back to good old Thomas Edison. You know, he may win eventually. So, you know, we're used to running AC around the world. You know, DC is a little different, but it's just different. It's not a problem, really. You just got to treat it properly. And, you know, right now, there's many vendors to select from for AC products. There aren't as many today for DC products, but that can change. And like I said, one of the other benefits you get from 380 volts DC is using the same philosophy they use in telecom central offices. You get higher reliability. These, you know, the telecom industry has proven that the 48 volt DC is really reliable. I mean, every time you pick up the phone, basically, you know, you can dial 911 or grandma or whoever you want to call, and it just works. So they've got a proven track record of high reliability. You get higher efficiency. You get actually, the data center can be smaller, you know, because the footprint can be smaller. And you actually end up with better power quality, and you can easier integrate renewable resources. So that's what I got.
Great, thank you.